Lesson 1-1, trig review, limits and continuity. Let's do a little trig, a little limits, and let's talk about continuity. Use the triangle at the right to find these three trig values. So for right triangle trigonometry, this is SOHCAHTOA. I want you to notice we're missing a side here. When you have a missing side of a right triangle, this is the Pythagorean theorem. A squared plus b squared equals c squared. You might also recognize it as a 3, 4, 5 triangle. So we first need to find that missing side, however you want to find it. Next, what's the definition of sine theta? Well, let's find where theta is. Sine, and we can write this out, SOHCAHTOA. So sine is opposite over hypotenuse. So that'd be 4 over 5. Tangent is opposite over adjacent. That's 4/3. Secant is the reciprocal of cosine. So it is hypotenuse over adjacent. 5/3. Little SOHCAHTOA review. Example number 2. Find the following if theta is an angle in standard position whose terminal side passes through the point -5, 2. Can you find these trig values? Well, let's plot. -5, 2 is approximately right there, let's say. Let's draw this. Let's label it. So this is -5, this is 2. So we actually have to find this missing side. If you like, it is a squared plus b squared equals c squared, and then we're going to solve for the hypotenuse. So that's 4 and 25, and then that's the square root of 29 to finish it off. Now we're not going to worry about rationalizing the denominator. We can leave in the denominator a square root. It's okay. All right, where's theta in all of this? So theta is here by the origin. Sine is opposite over hypotenuse. You could also think of it as the y-coordinate over the radius. Cosecant is the reciprocal of sine. So again, if it's helpful to have this to remind yourself, cosecant is the reciprocal of this. So it's hypotenuse over opposite. It's okay. It's been a while, I'm sure. Relax and do your best. Which one's opposite? 2. Oh, it's also the reciprocal of what we just did. Duh, right? You just did sine. Cosecant's the reciprocal. Man, there you go. Cotangent is the reciprocal of tangent. So that's adjacent over opposite. So that'd be -5 over 2. More trigonometry. Draw angles and make a reference triangle to find these. So 210, I don't know if you remember this. Since we start at 0, straight up is 90, 180, 270, back to 360. 210 is right here. And what we really need is the reference angle. And how to find the reference angle is you subtract it with 180. So 210 take away 180. This is a 30, 60, 90 triangle. And I need to know my special right triangles to be able to label this. So opposite of 30, opposite of 60, and the hypotenuse. We can also remember this, that a 30-degree reference angle, the order of the points is √3 over 2 and 1/2. Cosine goes with the x-coordinate. Because we're in quadrant number 3, the x-coordinate is negative, so this answer is -√3 over 2. 315, we need to know what quadrant it's in. So 1, 2, 3, it's in quadrant number 4, right here in the middle. If I take 360 and subtract 315, the reference angle is 45 degrees. That's √2 over 2 and √2 over 2. Another way to understand this, so tangent is the y over the x, or opposite over adjacent. When I divide these, I get the answer 1. But because we're in quadrant 1, I remember, if you remember this, all students take calculus that in quadrant number 4, only cosine is positive. So tangent is negative there. So the value of tangent at 315 is -1. I know it's been a long time, right? I don't want to spend forever on old trigonometry. We need to get to calculus, but it's good to be able to hopefully get that part of the brain going. Example number 4. Since 2 pi radians is 360, it follows that pi radians is 180. And the following common radian measure should be easy to think about in terms of converting each one. So pi over 2 is 90 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And pi over 6 is 30 degrees. Those should be common ones that you could translate very quickly from radians to degrees. Convert from radians to degrees or degrees to radians, whatever is given. So 5 pi over 4, we could do it the long way, which is to multiply it by 180 over pi. Pi's divide out. 4 goes into 180, 45 times, and 45 times 5. All of that is to give you 225. 270, that's at the bottom of the unit circle. So again, we can go 270 times pi over 180. That gives you 3 pi over 2. Negative 120, don't be worried about the negative. That means just the angle's negative in radians. So 120 times pi over 180. You can divide by 100, 12 over 18. 6 goes into both. That's 2 pi over 3. During the assignment, you'll get more chance to really work through it and see what you need to know in terms of trigonometry. Hey, draw angles in standard position and make reference triangles to find the following without using a calculator. So we're not going to do this. Instead, the denominator is 4, which makes it a 45-degree reference angle, which means it's root 2 over 2 and root 2 over 2. Negative 3 pi over 4 would end up, we have, first of all, a negative angle is measured clockwise. So negative 1 pi over 4 would be here. Negative 3 pi over 4 would be ended up in this quadrant. So that means both the x and the y are both negative. Cosine using this point, cosine is the x coordinate, and the answer is negative root 2 over 2. In number 7, cosecant 5 pi over 3. So because 3 is in the denominator, the point is 1/2 and root 3 over 2. 5 pi over 3. We go 1 pi over 3, 2 pi over 3, 3 over 3 reduces down. So the next numerator is 4, and the next one is 5. This is the quadrant we're in. And in quadrant number 4, x is positive, and the y value is negative. The definition of cosecant is the reciprocal of the y coordinate. So we take that, and we don't have to rationalize it at all. Just flip the y coordinate, and you have your answer. All right, number 8. A unit circle is created by letting the radius be 1. And since that, sine theta is the y coordinate, cosine is the x coordinate, and tangent would be y over x. So use a unit circle to find the value of sine at pi over 6. So the point at pi over 6 is root 3 over 2 and 1/2. So look at the denominator. It's a 30-degree reference angle. What's the y value there? And you have your answer. What's the value of sine at 0? So what's the y coordinate at 0? And the answer is 0. What's the value of cosine at 0? Right here, what's this point on the circle? And that point is 1, 0. So the x coordinate is 1. What's the value of sine at pi over 2? So pi over 2 is up here. What's the point up here? It's 0 and positive 1. So the y coordinate is 1. What's the value of tangent at negative pi over 2? You go clockwise. It's here at the bottom is negative pi over 2. What's the point down here? 0 and negative 1. Tangent is y over x. So that would mean when you do this, you divide by 0. This one is undefined or doesn't exist. The value of tangent at pi, that point is negative 1, 0. So when I go y divided by x, it's 0 divided by negative 1. That's 0. What's the value of cosecant at 3 pi over 2? So at 3 pi over 2, again, the point is 0 and negative 1. Cosecant is the reciprocal of the y-coordinate. So the reciprocal of the y-coordinate, negative 1. So if you think of negative 1 over 1, if you do the reciprocal, it's positive 1 over negative 1. There's your answer. What's the value of cosine at 3 pi over 2? That's just the x-coordinate there, which is 0. Enough trigonometry. Limits. Informally, a limit is a y value which a function approaches as x approaches some value. It's all about this word right here, approaching, not equal to. So when I think of what the y value is that it's approaching, that's my answer. What's the limit as x approaches negative 4? So can you find where negative 4 is? Go to the graph. What's the y value there? And the answer is 1. The limit as x approaches negative 1. So find where negative 1 is. Go to your graph. Notice we have a point here, but if I look at the graph, it's really approaching 4. This is way out of place. So if you follow the graph, the limit value is 4. If I ask for the function value, then the answer would be positive 1. Because the limit and the function value are not the same answer, this is not a continuous function. What's the limit as x approaches 2? There's a hole, but a limit exists at a hole if it approaches the same y value from both sides. So the y value here is 1. For number 12, the limit as x approaches 3. Well, here we are at 3. There's an asymptote. So we can say it doesn't exist, or both go in the same direction. We could also say it approaches negative infinity. But I'm just going to say it doesn't exist at an asymptote. The limit as x approaches 5. Here we are at 5. From the right, it's approaching 2. From the left, it's approaching negative 1. Notice how there's a jump in the graph. A limit doesn't exist where there's a jump, so this does not exist. Oh, I don't know what just happened. I think I'm still recording. I'm going to go for it. What did I say the answer was? Doesn't exist. Here we go. Number 16. No, those are limits. Now function values. So now we want to know what it equals. So at negative 4, what does it equal? And the answer is 1. So that means at negative 4, this is a continuous function because the limit value and the function value equal the same answer. At number 17, the value function at negative 1. So here we are at negative 1. What's the function value? That's positive 1. F at 2, there's a hole. So that means it does not exist. F at 3, here we are. Oh, we have an asymptote at 3, so it does not exist. And the function value at 5. So again, go to where the point is, and the function value is 2. Sometimes you can have one-sided limits. They have a little minus sign or a little plus sign. So with a little minus sign, it means you're coming from the left. So what's the value as you go from the left in terms of approaching there? Uh-oh. I feel like I've paused here. Is anything happening? All right, let me see here. Let me try. We're still doing this. My camera froze. You got to see one of my favorite hockey players. Can't find it? We'll go to the archive manager. Are you kidding me? Ah, all right, we're going to do this in two parts. One-sided limits. Well, the answer to number 14 from the left, the answer is -1. And then number 15, as x approaches 5 from the right, the y value is +2. So there's your answer on limits in terms of that. I'm very discouraged here. I'm going to unplug and plug in my camera. I'm not giving up here. All right, we're back, right? Okay. Next part of the lesson, I ain't quitting, here we go, is about continuity. Informally, a function is continuous where you can draw it and not lift up your pencil, but roughly, but for a formal definition of continuity, a function is continuous when its limit and function value are the same. In this course, we'll work with three types of discontinuities, and they're holes, vertical asymptotes, and jumps or breaks in the graph. A fourth type of discontinuity is an oscillating discontinuity. These rarely appear. Oscillating means it goes up and down, up and down, up and down around a number. To investigate this fourth type, you can graph y equals sine 1 over x on a calculator and look at windows close to x equals 0, and you would find that it oscillates in terms of that. So for example number 21, list the x values of discontinuities of the graph for y equals f at x graphed on page 2. So where are the discontinuities here? So when x equals -1, there's a discontinuity. Where else is there a discontinuity? So there's another one here at +2. And we have one at the asymptote. That's at 3. And we have one more discontinuity. Here at +5, there's a jump. All discontinuities can be labeled as removable or non-removable. And it's based on whether the limit exists. So which of the following discontinuities are removable? If something's removable, then the limit exists at that number. So at -1, did the limit exist at -1? Yes. So it is removable. So if the limit exists, try that again. So if the limit exists, it is considered removable. Here, again, the limit exists at -1, so it's removable. We just did that one, right? Here, how about at 2? The limit exists at 2, so it's removable. The limit did not exist at an asymptote, so the asymptote is non-removable. And at a jump, it doesn't exist, so it's also non-removable at a jump. So which of the following discontinuities are removable? At x values where a function is continuous, limits can be found just by direct substitution. So this is a continuous function, so you can just plug 3 in and get your answer. That would be, make sure you do order of operations. That's 9 times 3, that's 27 plus 2. For number 24, directly substituting is continuous at 1. It's not a discontinuity. So that's 1 squared plus 1 and 1 plus 1. That's 2 divided by 2. So that answer is 1. For number 25, again, a cosine is a continuous function. You can plug it in to get the answer. And the value of cosine at 2 pi over 3. 3 is a 60-degree reference angle. And the x value there is 1/2. 26. These are piecewise. When you have more than one piece that makes a function, they're called piecewise. This one has 2 pieces that change at x is at 1. So when it's less than or equal to 1, it's the top piece. When x is greater than 1, it's the bottom piece. What's the limit as x approaches 1? So that they have to be in agreement. So if I plug 1 into the top, the answer is 3. If I plug 1 into the bottom, the answer is also 3. Because they agree on the answer, the limit answer is 3. If I look at the bottom piece and do the same thing, if I plug 1 into the top, you get 2. If I plug 1 into the bottom piece, careful, you get 1. They're not the same. The top one gave you 2. The bottom piece gave you 1. Because they don't agree, the limit doesn't exist. That means for number 27, there's a jump at 1 because the y values aren't the same. For the same function g, find the limit as x approaches -1. Well, for -1, that just belongs to the top piece. So when x is less than or equal to 1, that's -1. You only plug it into the top piece because it just belongs there, and then answer it. So that's -3. This is -1, but a negative times a negative is positive. So that gives you the answer -2. A, one of my favorite functions, a step function, sometimes called a floor function, or a greatest integer function. Here are my steps. It says find the following limits using this. As x approaches 1/2. Well, that's in the middle, and the y value there in the middle is 0. The limit as x approaches 1. If I look at 1, there's a jump at 1, so therefore it doesn't exist. The limit as x approaches 5 from the left. So I don't see 5 here. I see 1, I see 2, I see 3. So it does keep going on. It's just a matter of then understanding from the left what it would be like. So you have 1, 2, 3. So 4 would be one more step up. And then 5 would be one more step up. So if I count 1, 2, 3, 4, but from the left, it would be the step below. So then the answer would be, oh, it's a totally different function. Ha. So plug 5 in, and you get the answer 7, but that's from the right. So if you think of it, at 1, 2, 3, 4, 5, this is what it would look like, but right below it would be the step below. So from the left, it's one step down or one step less, so the limit here would be 6. All right, turn the page. What? That's it? Hey, there's your lesson. That was on trigonometry. We're going to do this next. Different video. What else was it on? Continuity, limits. I'm proud of you for doing the lesson, doing it over again, and I'll see you when we do the assignment together. Mr. G Math, over and out.